So with right triangle trig, we're gonna go and we're gonna play in the bathtub. What? I'm talking about SOHCAHTOA. Right. It's a relic of the old times. If I have this angle here and I wanted to define the sign of that angle theta is my opposite over my hypotenuse. My opposite here is y, my hypotenuse is r. So it's y over r. My cosine, the big three of trig, the sine, the cosine, and the tangent. That's my adjacent, meaning next to, over my hypotenuse, r. And my tangent of my angle theta is my opposite over my adjacent, and that's going to be y over x. Very nice. So if you have a point in the plane, point, I don't know, what do you want to give it? 0.34? Sure. 3, 4, 3 in the x and 3 in the y, and they ask you to find the big three of trigonometry, you could plot that point in standard position. What they say is that an angle whose terminal side, an angle in standard position whose terminal side passes through the point 3, 4. So you could go over 1, 2, 3, up, 1, 2, 3, 4, put a dot. What that means is the terminal side of this angle, when rotating theta degrees, contains the point 3, 4. Sure. So if it has the point 3, 4, we can drop a perpendicular to an x-axis, or a reference triangle. So we make this reference triangle. This side here has 4 in length, that side here has 3 in length. That's a triplet, a Pythagorean triplet. We have here, we could use the Pythagorean theorem, but it's 5. So if we were looking for the sine of that angle theta, the sine of theta is the opposite 4 over the hypotenuse 5. Okay, but wait, there's more. The cosine of theta is the adjacent over the hypotenuse, or 3 over 5. And then once more, the tangent of theta just happens to be the opposite over the adjacent, which is 4 over 3. Tee-hee, tee-hee, and a box. And a flower.